Hi there. So I wanted to get you one more algebraic description example with a rational function. So we want to look at this function right here, and we're going to give an algebraic description for it. So remember that we always start with the domain, and if we have a rational function, we're always going to have to deal with that fraction. And so we're going to set the denominator equal to 0. You end up with x squared plus x minus 12 equal to 0. That's quadratic, so you could use the quadratic formula. Remember, what I always say is that if I can see how something factors, I'll factor it. And I can see this one factors pretty easily as x plus 4 times x minus 3. And so then I can solve each one of those. And remember, whenever we're finding the domain, we're finding things that are out of the domain. So we have those two. Remember, the other two things in general we check for are even roots and context, but we don't have either one of those. So if it helps you to draw the domain, here's a picture of the domain. Only negative 4 and 3 are out of the domain, so that means that everything else is in. So in order to actually write what the domain equals, remember you can break it into these three pieces right here and just pretend like each individually is the answer. So this interval right here is negative infinity to negative 4. Don't forget the middle interval. The middle interval is negative 4 to 3. And then there's this outer interval, 3 to infinity. And so we end up getting the domain. We have the parentheses because those numbers aren't in the domain. So you have a domain broken into three pieces. There ends up being kind of a general principle with rational functions is as many exclusions as you have, you're going to have one more piece of the domain. So that can help you, especially a lot of people forget that middle interval. All right, so now we get to the intercepts. So for the y-intercept, remember we said x equal to 0. If you go back to your equation up there, you'll see you end up with negative 3 over 12, which is 1/4. So our y-intercept is 0, 1/4. Now for the x-intercept, remember we said our function equal to 0. So whenever we do that, there's our function equal to 0. And you can either think about writing it over 1 and equating the cross products, or using the shortcut that the only way a fraction equals 0 is if the top equals 0. Whichever way you do it, you end up with the top equal to 0, so 2x minus 3 equal to 0. So you get x equals 3 halves, which gives you the x-intercepts, 3 halves comma 0. All right, now we go to the asymptotes next. And remember, there's two ways you can think about the vertical asymptotes. In general, you're solving for where the denominator equals 0, but we did that. We already did that when we were finding the exclusions from the domain. And so you can use work that you've already done. And so the vertical asymptotes are x equals negative 4 and x equals 3. And remember that subtle point. These are lines. We're actually given the equation of the line. So remember that x equals on both of those. All right, and now for the horizontal asymptotes, remember we make tables where x gets big for both positive and negative numbers. So if we look here, we make a table where x is getting big and positive. 10 to the 6 is a million if you don't know that. All right, and so you go and plug that in on your calculator, and you look at the y values you get. You get these, and the key thing is you're not looking exactly what these numbers equal. You're looking for what they're getting closer and closer to. And if you think about that, or you could keep plugging in bigger numbers to see that they approach 0. All right, and then if we look on the negative side, we're getting numbers that are getting bigger in the negative direction. And again, these all get closer and closer to 0, so they're approaching 0. So that's telling us that our horizontal asymptote is y equals 0. And again, that y equal, I know it might seem silly to you, but it's actually important because we're given the equation of a line. All right, now for the table, we need points around all the x-intercepts and vertical asymptotes. So we go and set up our table. Here, let's see, this is a vertical asymptote. There's my x-intercept. There's another vertical asymptote. And so then I just made up numbers in between and around all of those. All right, the vertical asymptotes I usually label as VA. You could write error or something to indicate that there's no part of the graph there. The x-intercept we give 0, and then I just went to my table and plugged in all these x values, and these are the y values that the calculator gave me. All right, and so I go and put together the graph. Remember, these are my vertical asymptotes, so I want to graph those as dotted lines. like that, and then I can go and plot my points. And I just realized my sheet already has the graph made. So, you would just go and plot your points down here like that. And oops, oh, I forgot my x-intercept. Like that. And then 2 is negative 0.16. Sorry, my brain froze there for a minute. And then forward 0.625. So it depends on how much experience you have with doing this, but you can kind of, especially on these ones where you only have 1 point. So if you don't, especially if you don't have a lot of x-intercept or a lot of experience, plug in more points on your table, and so that you'll see what's going on there, and you'll see that that part does this, this part does that, and this part does this, like that. You'd need more detail on your graph. I'm going to show you a better graph here in a minute. All right, but again, try to get over that habit of guessing what goes on with the graph. Instead, just go to your table and plug in more points and plot them. You don't even have to write them down. I just want you to be getting them correct. So anyway, you put all that detail together, and you end up with this interesting looking graph to me. All right, and so then we need to get to the range. And so remember, the main problem, we're going to see at least one example where there's even a little bit more thinking to do. The main issue is whether or not the graph crosses the horizontal asymptote. And the horizontal asymptote is on the x-axis. And so notice right here, the graph is crossing the horizontal asymptote. So, right, most of the question we've been asking is whether or not the graph crosses the horizontal asymptote. Another way to think about it is, remember, the range is the y values on the graph. So it looks like from these parts of the graph, 0 gets excluded from the range. But if you look carefully, this part's crossing it, so it actually doesn't. Another way to think about it is sometimes the range will end up being negative infinity to infinity, and the way you can spot that is if there's any single piece of the graph that has that range, then the entire range is negative infinity to infinity. So if this were all the problem was, the range would be pretty easy to figure out, negative infinity to infinity. So since that part of the graph has that range, so does the entire function. Alrighty, I hope that helps.